This is the exercise 5 and the final exercise for the week 9 in-class exercise demo videos that excuse me, are going to be available to you. This one is an example of how to use a slider as part of a temperature conversion application. In the window, you can see we have a box with a read-only value for Fahrenheit, a read-only value for Celsius, and a slider at the bottom. The slider at the bottom represents various Celsius temperatures, and as you move the slider, you will get a Celsius temperature and the corresponding Fahrenheit temperature, even up to 100 degrees Celsius, which is boiling for, 212 degrees Fahrenheit, the boiling point of water. This moves between the freezing point of water, 32 degrees Fahrenheit, 0 Celsius, up to 100 degrees Celsius, 212 Fahrenheit, or the boiling point of water. So we're going to talk about how to put this application together and how we've done that in the code that we see. We've included a number of libraries, most of the ones that we're used to seeing: the Swing library for layouts, the Swing library.events for event handling. Again, we could pretty much use that interchangeably with the Abstract Window Toolkit's event library. Some of the components that are Swing library created often have their own Swing library event that we need to deal with. We have our Abstract Window Toolkit for our layout managers, and of course, the extra one that you see is the decimal format class, so that we can format the result of our Fahrenheit to Celsius calculations. We've got 2 J labels that we've created here in our temperature converter class that, of course, extends our J frame, so it's going to be a window. We've got 2 labels. One is going to be used for the to label the Fahrenheit temperature, the other for the Celsius. We've got 2 text fields, one for the Fahrenheit temperature and one for the Celsius. We've got a Fahrenheit panel, a Celsius panel, and a slider panel. And then, of course, our J slider object, which is the slider that we're going to be using. In our constructor, we're going to set the title of the window to to be temperatures. We're going to set the default close operation so that the program closes when the window is closed, or the program ends, I should say, when the window is closed. We're going to create our 2 labels, call one Fahrenheit, call one Celsius. We're going to create both the Fahrenheit and the Celsius text boxes with initial values. We're putting 32.0 in as the Fahrenheit temperature. We're going to make it a length of 10 characters, and we're going to not make it read only. When we create the Celsius text field, we're going to set it to 0.0 as the text, and make that 10 characters as well. We're also going to make that read only by calling setEditable and providing false. We're going to create the J slider. We're going to make it a horizontal slider, so it goes from left to right as opposed to top to bottom. We're going to start at 0 and end at 100. Let's see here if I can get the... we're going to show the Java docs here, so we can take a look at the constructor that we're using. My internet's a little slow tonight. So, and the last item that we're providing is the initial value. Now, of course, if you ever forget what the various options are for something, you can always go to the Java documentation. Usually what I put in when I search Google is I put in the name of the class, in this case J slider, and the the word Java, space, and then the word Java. That searches for both the class name and Java in the same document. Usually my first couple of results are the Java documentation. Of course, when you're in NetBeans, you can right-click on the item and do Show Java Docs. So the constructor that we've chosen to use is the one that takes in the orientation, the minimum, the maximum value, and of course the initial value. So in this case, we are providing, it's going to be horizontal. We're starting at 0, we're ending at 100, and our initial value is going to be 0. We're setting major tick spacing at every 20 and minor tick spacing every 5. We're calling the set paint ticks to show the tick marks. We're calling set paint labels and providing true to display the numbers. We're adding the change listener. We're adding a class that implements the change listener interface to permit us to listen for the slider events. When the slider is changed, we're going to update the 2 text boxes. So we need to make sure we handle that event. We're going to create our panels and place our components on them. So I'm going to create the Fahrenheit panel. I'm going to add the Fahrenheit label and the Fahrenheit temperature text box. I'm going to create the Celsius panel, add the Celsius label and the Celsius text box. I'm going to create a slider panel and add my slider to it. I'm going to set my window to use the grid layout as opposed to the border layout. I'm going to create a grid with 3 rows and 1 column. I'm adding the Fahrenheit panel to the first cell, the Celsius panel to the second cell, and the slider panel to the third cell. I'm calling pack to get my window nicely sized, and I'm calling the set visible method and providing it with the Boolean value true so that it becomes visible to the user. When the slider is changed, we want to take that Celsius temperature, calculate the correct Fahrenheit temperature, and display the Celsius temperature and the Fahrenheit temperatures in the text box. So we're going to we have this class called slide listener, and we linked slide listener up with our slider through use of the add change listener method. That means that we have to implement, that this class has to implement the change listener interface because the slider sends out a state changed event. It generates a state changed event. So in order for the Java virtual machine to call the correct method, we have to implement the change listener interface, which has one method called state change that we must include in the body of that class in order for everything to work. When the slider is changed, no matter how far it is changed, it just moved a little bit or moved a lot, the state changed event is a change event is fired or executed or thrown, and the state changed method is called. It takes a change event object, and inside the state changed method is where we put our code with what we want to happen when the slider is adjusted. Anytime the slider is changed, of course, we want to get the Celsius temperature from the slider, convert it to a Fahrenheit temperature, and display both the Celsius temperature and the Fahrenheit temperature. In the case of the calculated Fahrenheit temperature, we're going to limit ourselves to one place after the decimal point. And for that, we're going to use the decimal format class. In order to get the current value of the slider, wherever the little knob sits on the slider, I'm going to call the getValue method. That is going to place the decimal value into the variable called Celsius. I'm going to do my conversion, 5 divided by 9 times Celsius plus 32. It's usually 5 divided by 9 times Fahrenheit minus 32. If we reverse it, we're going to add 32 and then multiply it by 5 divided by 9 to get Fahrenheit. Once I have done that, I'm going to store the result in the Fahrenheit variable. Then I'm going to set the text of the text box to the Celsius temperature. To get a decimal value to appear as a string for use in, say, a text box, we can call the double wrapper class has a toString method, and then you just provide it the double value you want converted to a string. Finally, we call our decimal format class object. We call the format method, provide it Fahrenheit, and that's going to spit out a string that we're using the setText method to change the Fahrenheit text box. So this has been an overview of of how to use our slider class and how to handle events from the slider using a pretty cool Celsius to Fahrenheit converter. Again, the slider is giving us our Celsius value, which we're displaying here, converting to a Fahrenheit value, doing some formatting on, and then displaying in the text box. I hope you enjoyed watching these videos, and I hope you were able to understand how all of these components work. Again, I apologize for my voice. I'm rather congested thanks to my allergies. I hope you enjoyed this. Of course, if you have any questions about any of the exercises we've talked about this evening, you can feel free to email me, bsimbeck@ccac.edu, or bring your questions to class, and I'll do what I can to get them answered for you. Again, I hope you enjoyed this, and thank you for watching.